about how a database can or maybe doesn't affect your applications. I'm going to take, as Alex said, I'm going to take some different databases today. We'll walk through applications with those and actually kind of show off Spring. So if you guys are familiar with Spring Boot, Spring Data, things like that, this actually kind of showcases Spring technologies, but talking about it in regards or as on a focus of the database itself. And then, of course, talking about how the application interacting with those databases, whether it changes or not. My contact information is down there in the lower left-hand side. I've got it again on the next slide and then again on the last slide. So don't panic and try to jot everything down. And then I think Alex said he would also throw some of these out there as well. So feel free to contact me afterwards. I'm happy to answer questions or continue discussion even after today's session. So with that, let's kind of just briefly, I'll give you a quick history of me. I'm a developer relations engineer at Neo4j. I like to write code, and then I like to basically turn around and share what I've learned or share the code, show others my experiences and what I've learned along the way. So I do that in a variety of aspects, whether that's blogging or conference speaking or like online, meetups or groups or events like this. And I really enjoy that. So basically, a lot of things boil down to, even in my kind of off personal time, I'm kind of just a geek and I enjoy being that way. So I like doing all sorts of things. So again, contact information down there in the lower left, and feel free to ask questions here today along the way or at the end. Okay, so why does the database matter to us? Well, first off, there's a couple of different kind of aspects of this. First off is the long term. You want the right tool for the right job, right? Otherwise, it's not going to last very long. People are going to hate it all the way through. And a lot of times when you put a system into place, you don't really rip and replace all that often. So you want something that's going to have good longevity, something that's solid, something that people like working with. And then you want something that's easy to maintain, easy to improve upon, easy to add features or go back and fix code, etc. So long-term aspects, you want to make sure you pick the right thing, but there's also short-term aspects. So mostly it's just kind of the current project you might be working on. If you force data into an unnatural format, that makes it really hard to remember or kind of uncomfortable to jam in and correct right. Maybe you have to do some data manipulation. If the data model isn't super clear because you're kind of pushing it to something it doesn't really fit into, then that causes confusion, lots of iterations trying to figure out, well, does this go here? Does it go there? What is the best place for this field or this aspect of the data? A lot of times you'll end up writing some really complex queries, which of course, as we know, can provide some maintenance headaches or even just kind of tweaking or fixing headaches. And then data storage can actually impact your application development, which we'll look at. Although Spring provides some really nice things out of the box that actually lowers that impact quite a bit. All right, so I'm going to take 3 different databases. Each one of these databases is kind of the, I won't say key, but I would say probably one of the ones that bubble up to the top in each of their respective spaces. So MariaDB in the relational database aspect, it's basically an open source version of MySQL. So kind of one of the main flavors, just kind of an open source version of that. MongoDB is the document database. And most of you know it kind of led the NoSQL category. And then Neo4j, definitely the leader in the graph space. And so we'll take a look at relational, document, and graph and see how those are different and how your applications look different, and then maybe how the different types of databases might impact your application. Okay, so I'm going to take a really kind of standard use case. So the Northwind sales system, if you've done much with databases at all, you've probably come across this data model. But we're just going to stick with this for today. And we're actually going to focus in on a very narrow portion of that. But this is kind of the whole broad Northwind sales system that you'll probably, if you're testing or playing with or student of database classes, you might import this data. So it's orders and products, and then you'll have some customers and employees that manage the orders and suppliers and the whole chain basically there. We're just going to focus in today on orders and products, and I'll talk more about that in just a second. But this is the data model that we're going to be dealing with. So why would I want to use Spring? Why am I using Spring today? First off, As you might imagine, I'm going to be coding 3 different applications running against 3 different databases. That's a lot of code in a small segment here. So Spring really provides a lot of quick start abilities out of the box. So the first up is their Spring Initializer, which I'll show and walk through that here in just a bit. Spring Boot reduces a lot of the boilerplate, which is excellent. So it reduces the amount of code that I have to write today. And then Spring Data provides consistent integration. So it gives you annotations for mapping your plain old Java objects, your domain model classes, repository support via an interface, which we'll look at, and then a DSL or domain specific language that you can write queries for each type of data store that you're dealing with. So I've got the full list of Spring Data projects there on the right-hand side, and there's the link there down on the lower left or lower right, excuse me. And then I've highlighted the 3 that I'm going to use today. So Spring Data JPA is for relational databases. It connects to a variety of relational databases. We're just going to use it with Maria today. And then Spring Data MongoDB obviously connects just to MongoDB. And then Spring Data Neo4j connects directly to Neo4j. So those are the 3 that we're going to be dealing with today. All right, so these are the 3 different data models, and we'll kind of do a zoomed in look at each one of these. But again, we're just dealing with orders and products and the relationship between those. So let's take a look first at the relational model. If you've done a whole lot with databases, you might be most familiar with this model. So we have orders, and I've stuck with just a basic primary key, the order ID, and I've put an extra field on there of the order date. We want to know what day that the order was put in. And then we have products on the right-hand side there. We have a primary key of product ID. We have a product name field that I've also added just so it makes, kind of helps us understand what product it is. And then when we want to find out basically the relationship between these 2 things, okay, what products are being ordered and how many orders does a product have, you end up with this, it's a many-to-many relationship, right? You have an order, it could have multiple products on it. For a single product, it could be on multiple orders. So you end up with this many-to-many, and so you'll create this associative entity or join table in the middle that basically leaves us with a one-to-many relationship. As you can kind of see my cardinality on the lines there between the tables. So in the middle there, we have that join table, and then the primary key becomes a composite primary key of both the order ID and the product ID to give it a unique row. And then we also are storing unit price, discount, and quantity. That basically these are our invoice items. These are our line items on our order. So it tells us, okay, what was the price they got this item for on this order, if they got any discount, and how many they ordered. So that's the relational model. Mostly pretty standard, nothing really fancy or complicated, hopefully there. Now let's dive on over to the document database. So this one nice thing about MongoDB and document databases is you can nest documents. So you have this kind of hierarchy or substructure inside your document. So that's exactly what I've done. I've taken advantage of what Mongo provides and dumped all of my line items basically into the same order. So if I want to search for orders, it's going to pull all of the line items and all the details about those line items back. I'm not storing product separately. I absolutely could. But for this instance, I really want to know how products are related to an order. So for me, it made the most sense to store those as line items on the order and then just pull orders. So I've done that. I have a primary key. That's the kind of Mongo BSON type ID there at the top. And the order ID is kind of the natural key or the technical key, if you will. And I also have order date there. And then I've nested those, that products basically as a sub document where I have the product ID, the product name, and then the unit price, quantity ordered, and discount if they got any. So that all appears on the same document, basically, just as substructures. And then finally, we go up to our graph model here, which is the one I'm most comfortable with, maybe. So we have our order node, our order entity, and again, we have our order ID and order date. Same thing on the product side, product ID, product name. And then we have a kind of a physical join, if you will, but a relationship between the two that then I can store properties on that relationship as well. So quantity, unit price, discount. So while it kind of looks similar to the relational model. What's different about graph is that those joins are not computed on runtime. They're computed physically in the data store. So when you query, you're just querying what's already in the data store. So it looks more similar to the relational model, but the physical storage aspect is different. Okay, and with that, it's time to dive into code. We're like 14 minutes in and we're ready to code. So let's switch gears here. So I'm going to go over to, let me see if I can zoom this in. Hopefully that's nice and clear. Okay, and we're going to start out with start.spring.io. This is the Spring initializer. Oh, this is the Spring initializer. So this is basically where I can kind of compile project components, my dependencies, the name of the project, and it will put everything, the basic skeleton structure of the project together for me, and create a main method in my class, my project class. And that's pretty much all it does for me. So I'm going to do that. We're going to call this code wars. And we're going to leave all the standards. Oh, I did want to actually change. I'm going to, instead of using the latest release of Spring Boot, actually came out last Thursday, so less than a week ago. And I switched everything over to 2.6.0. Everything seemed to work fine. But when I ran my demo from start to finish, because of the way I'm running the demo, I start with MariaDB dependencies, and then I just comment out and add my new dependencies as I go along. For some reason, some of the dependencies and versionings are not getting cleaned out. And so it's causing a problem when I do that. But if I go back to 2.5.7, everything works phenomenally. So I'm working with engineers on that at Spring and Neo4j to see if I can figure out what is causing the issue there. It's actually when I go from MariaDB to MongoDB. So I'm not sure what's not getting cleaned out, but I don't know if it's IntelliJ or Spring Boot or what, but something's not happy. So I'll go back and fix that. And hopefully in the next week or two, by the time you guys recreate this or what have you, it'll all be completely magically fixed. But until then, okay. So first off, I'm going to start
Jennifer,
with Spring Web.
Interrupt.
This will allow me to create.
It's a little bit blurry. Did you share your full desktop or did you only share a window?
No, I shared the full desktop.
You shared full desktop. Okay, then I don't know what the cause of it is. Then, yeah, I think
that's a little better.
That's a little better. Yeah.
Okay. Yep.
Okay,
I'll just make sure to zoom in. I have a wide monitor, so I'll make sure I
all right. Cool. Thanks.
Zoom everything in on that. Yep. Thanks for letting me know. Okay. So my web dependency is going to allow me to create a REST API. This will allow me to pull data from each of my databases from the application using REST endpoints. And then I'm going to use Lombok for today. Again, it's just everybody kind of has their own opinions on whether to use Lombok or not. Some people hate it, some people love it. But for today, to shortcut some of the code that I have to write, it works phenomenally. So I'm going to do that today. And then I need my actual database dependencies. So I want to put in Spring Data JPA, which is going to allow me to connect to relational databases. And it does connect to a variety of relational databases, not just Maria. But then we're going to select MariaDB driver specifically so that we have that, that it'll expect MariaDB connection. Okay, so let's generate that. And we can dump it into downloads. That's fine. Open the zip. And I'm going to open that in IntelliJ. And let me fix, I'm sure it'll open up into kind of some small font. So let me fix that really quickly. Or hopefully it looks a little better. Okay. And then I think there's, nope, it is, I think it's editor. Oh, no, that's just general font. There's a color, high contrast. There we go. Okay. Alrighty, so let's try. Let me bring up my Palm and see. Oh, that code, that's still rather small. 1 second. So I do need to change the font here as well. There we go. Hopefully that is better. Okay, so we have our version of boot right here, 2.5.7. And again, that's not the absolute latest version of it. because it's a little bit buggy, but it is second to latest. And then Java version 11. And then we have our dependencies in here. So Spring Data JPA, and then our web dependency for the REST API, the MariaDB driver here, and Lombok. So that is all ready to go. And I'm going to drop into my application.properties. Now, so I don't have to spend a ton of time here, I've actually just templated these. So I have, because I'm running 3 different databases in Docker containers on my device here, I need to have the application connect to each a separate port so that I'm not overlapping communications. So you'll see this example in all of my applications that I do today, but I'm going to have MariaDB running against 8080, MongoDB against 8081, and then Neo4j against 8082. So I've got that one in there to tell the application, hey, talk on this port. And then I need the database connection. So I've got a URL there for MariaDB. I've got my authentication information, super secret, I know. And then my driver. So where to find the driver class there. And then this actually is the setting that you want to use in production. But this just says, how do I want my application to sync with the database schema? You can actually have the application update the database schema on the back end. You can have the application take whatever's in the database. You can have them kind of sync together if you want to, where each of them kind of make changes to each other. This, however, I don't want any syncing going on at all. So I have this variable set to none, or this property. And this is the one that they say you want to use in production as well. So that is there. And then this, because some of these 2 properties here, some of the naming doesn't quite line up. So I named some of my database fields, and then I'm writing the application. I'm like, I don't really like, that database field, or it doesn't really make sense in the application context, or I don't, because I'm writing in Java, maybe it overlaps with a Java keyword or something. Then I changed the name of the field on my application side. And so then I need to be able to map it back to the database. And so these are 2 strategies that I have set up in order to do that. So that is there as well, but nothing super crazy. Okay, if you have more questions about that, feel free to ask later down the road too, but that was a quick fly through that. Okay, so let's just start our application. We have a class of order, because if you recall our data model, we have orders and products, and then kind of the relationship between those. So let me get this off the screen. It's kind of annoying. Okay. Now, I'm using Lombok, so I'm going to use the data annotation, which gives me all of my getters, my equals hashcode toString methods, etc. It does that all for me out of the box with that annotation. Then I'm going to have a noargs constructor. Again, this is Lombok annotation, so it creates a constructor with no arguments. And then a required args constructor. Again, a Lombok annotation creates a constructor with only the required arguments. And then I need to define my JPA entities here. So in fact, I usually put this one first, entity. So this is a JPA entity. I need to tell Spring that, hey, this is a domain object. This is an entity class for an entity on the database side, etc. And then I need to map it to a particular table. I don't know what I just hit there. Name equals orders. And notice that there we go. I just bookmarked it apparently. Okay. So this here, notice that it does not match my class name. I wouldn't normally have to put this property in here, but because my database table is not named order with a capital O, it's actually named lowercase o with a plural on the end, then I have to tell it specifically, hey, look for this table when you go to the database. So that's what that's doing. Okay, I need an ID field, and then I'm using a Lombok annotation to say I expect this field to be not null, and then this is going to be our order ID. And then let's do our date and order date. So those are the 2 fields that we're going to do for our order class. Super basic, super small, nice and condensed. Okay, so now let's go to the other side. And let's do, let me just start here, our product class. So again, we're going to do our data annotation, our noargs constructor, oops, helps if you can type, and our required args constructor, and then our at entity, and our at table. And then again, my naming wasn't too brilliant on the backside, and I did it like that. Okay, so same thing on this side. I need an ID, I need a non-null, and then this is going to be our product ID. And then I also want to have a product name. Okay. Oh, I usually do the repository. So we'll come back to the product side in just a second. I'm going to go ahead and code my order repository. So we're going to call this order repo. And then that's our interface for the repository. And then I want it to extend the CRUD repository, which then I needed to tell what object I'm tracking, which is the order object. And the ID type of that object is long, as you can see up here, long order ID. And that's actually all I need to do for my interface. Nothing extra on there. No, annotations or, anything that I need to define. The reason for that is Spring actually provides some built-in methods out of the box for you. So things like find one, find all, find by ID, all of those methods, they pretty much figure that across the board, most of your implementations are going to be the same. Some exactly the same. So what they've done is they've provided basic implementations for those methods out of the box. And then if you need to customize those or you need to write your own methods, by all means, they allow you to do that through some of the annotations and DSL and things like that I talked about. And we'll actually walk through that here in just a minute as well. Okay. So now we have our order controller. So we need to have a controller in order to point, create our, or kind of define our endpoints and allow us to connect to the REST endpoints. So this is a REST controller. Yep, REST controller. And at request mapping, and I'm going to say /orders is where I'm going to access this information. And then there's an all args constructor that I want as well. So I need to create a constructor with all the arguments. And then I need to inject my order repository. There we go. And now I can start creating my endpoints. So get mapping. I'm just going to leave the basic endpoint as the order. And we're going to say find all orders like that. And then return order repo.findAll. Okay, and that's all I need to do. Now notice in my repository up here, I did not define a find all method. But as you saw, all I had to do was inject my repository, call it, and say, oh, look, there's find all, find by ID, save, find by ID, save all equals hashcode, all these that are provided out of the box for me. So find all is one of those. And so that gives us a good starting point. If I now run the application, now I should be able to see all of my orders come back. And let's see if I switch. It doesn't like it when I do this. Okay, so here, where did my browser tab go? Love it when it does that. Not. Okay. There we go. Okay. Localhost port 8080/orders. Remember, my application is going to port 8080. I'm running it locally, so I don't have to put in a specific address there. And then my /orders endpoint is where I defined in order to access the find all method. So I do that. Let me zoom this in so you guys can read that. I have the order ID and order dates for all kinds of orders. Now that's great, but you might say, hey, you haven't really connected it to anything. All we're getting is just the basic order details. You are correct. Let's switch and go back to IntelliJ. And we'll start kind of looping this product and the relationship into that. So we have our product already defined. That's there. Let's go ahead and do that. We're dealing with relational database. So we have that associative entity or join table in the middle. So we need to define that. So we have our class. We're going to call this ordered product. And then same thing here. We have it at data, at no args constructor. Now we need an all args constructor here because this is an entity that's tied to two other entities. And so we want all the arguments involved in this entity because it's connected up. And then we need to define it again as another entity because it is a separate table in our database. So again, naming not super great here on the database side for me. So I'm going to sync that. And that should be good. So we have an ID, we have a non-null, and then private long. Now with relational databases, you can have composite keys. So that's what I've done here. I've defined both the order ID and product ID to create a unique row on that join table. And that's my composite key. And then I also want to define a couple other details that are line item about the line item. So we have the quantity that the person ordered, then we have the discount that they got and the unit price that they paid for that item. Okay, now that's great. We still haven't connected all the dots though, right? So let's go back and do that. Oh, one other thing, because this is a join table and associative entity, and because I have a composite key here, I actually have to specifically implement the serializable interface here. So you don't have to do that. There's a couple of, most of the time it just automatically does it, but there's a couple of caveats. One of those being the composite key that I've used here, that it requires you to specifically implement this serializable class here. So I have to do this, have to specialize it, or it'll kind of throw errors at me when I run it. Okay, now let's go back and add our relationships here. So an order can have multiple products or can have multiple line items, right? So we're going to say we have a one-to-many relationship, one order to many line items or many products. And so this is going to be mapped by the order. And then this is just specifying a couple of properties. If you're familiar with relational database and all that good stuff, this might be familiar, but basically I'm saying that, okay, the cascade, if I make changes to an order on that table, I want any changes to line items or whatever to cascade on down to the child tables. And then orphan removal, if I have line items that aren't connected back to an order, I want to go ahead and remove those. So for some reason, if you delete an order, but you don't remove the line items off that middle table, then this is going to go ahead and do that. Okay, and then we have a list of ordered products, and we're going to call this, after I do the import, ordered products. There we go. Okay, so that's in good shape. Now let's do, I'm going to skip down to the product side and basically do the exact same thing, just on the other side. So we have a one-to-many. A product could be on multiple orders or has, multiple line items. So mapped by, this is going to be on the product. And then cascade, we want the same thing here. We want, if you remove a product, you want that maybe to cascade, you might not, because maybe you want to leave those orders intact for previous products. But in this case, I'm just going to go ahead and remove that and clean all those up. And then we have a list again here and ordered product again, because that's our middle ground is our line items. And then I'm just going to call this product order so we can keep them straight. Now let's tie that middle table back to the other two tables on either side. So we can have multiple line items, so multiple rows that tie back to a single order or a single product. So it's a many to one. Then we have to tell it which column are we joining on. So in this case, the name of the column is order ID. We're going to start with the order side here, and then insertable false and updatable false. Again, same thing here. You don't want somebody to insert a line item that's not tied to an order, or not tied to a product that exists in the system. And you also don't want them maybe to update a line item without first touching the product or the order tables on either side. So that's what I've done here. And then private order. And then same thing, just now to the product side. So join column, name is product ID, insertable false, updatable false, and then private product. Okay, so there's actually one more thing I need to do, because now that I've tied all these things together, what's going to happen is we're going to pull our orders, which is going to pull all of these fields. So order ID, order date, ordered products. That's great. Ordered products is going to go over to the ordered product table here, and it's going to pull all these fields, order ID, product ID, blah, blah, blah. And it's going to go down and pull order and product. Well, we just came from order, right? Well, it's going to go back and it's going to pull all these fields again. Guess what? It's going to go back to this table and it's going to go back and pull order, and you get this lovely circle. Same thing's going to happen on the product side, even if we start from order, because they're all now linked. So you come across to the ordered product, it's going to go down to the product. Guess what? Product is tied back to ordered product. So it's going to go here, and you'll get this lovely infinite recursion error if you run this as it is. So what we need to do is kind of limit it in some way. So we're going to say JSON ignore properties. So ignore the properties. When you go over to ordered product, we're going to ignore order because we're coming from order, right? So, okay, I want to ignore order. Now, actually, because I'm coming from order, I also have order ID already because I've got that there. And when I go over to this ordered product, it's going to try to pull order ID again for me. So I don't want duplicate data showing up on my screen. So I'm actually going to tell it to ignore order ID as well. And then when I go over here, it pulls product ID there, but it's also going to go on over to the product table, which also has product ID and other stuff. Again, I don't want that duplicate field on there, so I'm just going to tell it to ignore product ID as well when it goes over to the order product side. When I get to the order product side, what I want to do is I want to tell it, hey, when you, if you're starting from order products and you go back to order, we just want to ignore ordered products because we're already coming from there, right? So we're just going to say ordered products there. And I'll basically do the same thing just here. And then this one we called product orders on the product side here. And then I need to tell it, hey, when you go across to that middle table, the ordered products table, I want you to ignore product because we're coming from product here. Then I also want to ignore order ID and product ID, just like I did on the other side. So that way you're not getting duplicate information there. Okay. So that's in good shape. Let's rerun this. Let's see now. This is just kind of, again, nothing fancy here. We're just using a find all method. Let's just see if we've got our relationships now intact when we pull those, pull that data. Okay, switch to here. So just rerun this one and it'll format. I've got a browser plugin that formats the JSON really nicely for me. So I have to wait an extra second for it to do that. Okay, so now I have orders and I have order dates, and now I have these line items coming in. So ordered products, it grabs the line item information, the quantity they bought, any discount, the unit price, and then it goes on over to the product table and it pulls the product ID and the product name off that. So my relationships are working. I'm starting from the order table, getting the order object. Within the order object, it's got multiple line items. As you can see here, this particular order has 3 line items on it. So this one, it's queso and fried meat and mozzarella, it looks like. So it's getting then the line item stuff and then on over to the product to get the product information. So that's working really well. And you can scroll on down and look at a variety of other options here, but there's tons of them. So now we want to take it just one step further. I've showed you just kind of the built-in find all method, but what if we defined our own methods? It did something different here. So let's say we want to do a find by ID. Let's say we want to find a particular method. So find order by order ID. Again, Spring kind of helps you along by suggesting, hey, you might want to find this particular thing or this particular object. So it'll suggest some method names to you. And behind the scenes, it kind of builds the query for you. So you don't have to specify every query. However, if something's not quite right, or the method name is getting super long and cumbersome, which they can, then you can absolutely use a custom query, which I'm going to show here in just a second too. So order ID here. So we're going to pass in particular order ID, and we're going to hopefully find that order. Now, let's say I want to write a custom query here. So with, I mentioned domain-specific language, DSL. So for each different type of database, you can use the query language that suits it. In this case, we can use SQL, or specifically what's called JPQL, which is Java Persistence Query Language. That means that I can actually reference my application entities instead of direct table names. So here I'm going to do select, it's SQL, but I'm using my application entity. So remember that my database table is not named order with a capital O. It's actually orders with a lowercase o. And so again, this is the JPQL side of it. I can use my application entity. So select order O. Oh, hang on. O from order O. I can't write SQL. Okay. Now enter join O dot ordered products OP where this is my join. I'm going across that ordered products table, that middle table there, where op.product.product name. So grabbing the ordered products join association table, and then pulling the product field off of that. And then in the product field, it goes on across to the product table, which has product name as a field there. So it's kind of this long series of chaining things together. Where the product name, I'm going to do a fuzzy search. So let's say I would want to find orders that have maybe, coffee or chocolate in the name. I want to find all the orders where they ordered coffee. And so that's what this query is going to do. I'm going to look for all of the orders where somebody ordered something that's named close to my search term. Okay, so now I'm going to say we're going to probably return multiple orders because, again, it could be a fuzzy search. That's what I'm doing with this like and the percent signs. So possibly multiple orders coming back. I'm going to say find orders by, I'm just going to say product. So again, custom query. I can name this method whatever. So string product name. Okay. So that defines it there. Now I need to actually implement it on the REST API side. So get mapping. I'm going to call this find by ID. So that's the endpoint I'm going to reference to get to this query. Order, find order by order ID. And again, I can name it anything I want to here. I'm just kind of trying to keep things mostly standard. Return order repo dot find order by order ID, passing in the order ID. Okay. Yep, all good there. Just took a minute for it to catch up. Okay, and then find by product. So this is going to be my fuzzy search one. I will probably have multiple orders coming back, potentially find orders by, I'm going to say product, kind of shortcut that because that could be really long. Name, return order repo dot find order by product, pass in product name. Okay, now if I've defined everything properly, this should run. Let's find out. Okay, so we will switch over to my browser tab. So far it's happy. Okay, so now our endpoint, and remember our additions are find by ID, and I need to pass it an order ID. And let's just look for, how about 10414? Sure, why not? Okay, so we have our order ID, our order date. Then it grabs the line items. So we get the quantity, discount, unit price, and it has two products on our order here. We have tea time chocolate biscuits and Guy Toast. Pardon my pronunciation on that. But this endpoint is working then. So I can search by any particular ID. I could even search by one of the other one I use a lot is this 10564. This looks like 3 products on it. So that's all returning. I can search by any order ID, and assuming it's in the system, it'll return something for me. Okay, so now let's go to our other endpoint. So find by product, we have a product name that we need to pass in, and let's actually just search for coffee. I love coffee, need a lot of coffee today. So I have my order ID, and then notice there's the IPO coffee. So this is the full product. It's doing the fuzzy search for me because coffee is the second half of this full product name. And I've passed in a lowercase c, and it's finding it even with an uppercase C. So it's doing that fuzzy search really well. and I can scroll on down. Looks like everything is IPO coffee. It doesn't have anything else. And it's pulling all of the line items that are on that order. So it grabs the order where coffee is a part of it, and then it grabs the line items and the products that are related to that. So that's all working. And I can even search. I also really like chocolate, so I could search for anything with Choco in the name, which pulls tea time chocolate biscuits. So there's our Choco, nice in the middle of the word and everything, and ignoring the case. There's also, if I scroll down here far enough, there it was actually. Chocolate. So it finds this product as well. So again, the fuzzy search is working. It's pulling back multiple products with these situation of letters there. And then I could even go one step further and just look at chocolate specifically and notice then that the tea time chocolate biscuits disappear. And it's pulling the coffee because it's on the same order as chocolate here. So that's all working. We're getting our entities back, and the fuzzy search is working on our query there. Okay, now that is MariaDB. That's pretty cool, pretty basic, but let's mix it up. Let's go over and switch to MongoDB. Now you might ask, oh my goodness, this is probably going to be super complicated, right? Wrong. That's it. One dependency change, one word, that's it. You just have to change the Spring Boot Spring Data dependency here. Instead of JPA on the end, it's MongoDB. Thankfully, their naming is all consistent on their libraries. So all I had to do was change this to MongoDB and resync Maven, and it pulls in all the dependencies for me. I'm actually going to comment out the MariaDB driver dependency because we actually don't need it, right? We're done with MariaDB, at least for now. So we'll do that. And then of course these won't work anymore. So I've got these also for Mongo situated in there. So again, new port for our application because we don't want it to conflict with our Maria application that we had open. The database connection details and the authentication to get into the database. Nothing new or crazy there. Okay. Now you can see we go back to our code and it's got all kinds of red. Let's go and fix that. So this is now showing you how, okay, if you switched from MariaDB to MongoDB, what kind of impact is that going to have on your applications? So instead of entity and table annotations, you're going to use the app document. MongoDB, their data model deals with documents instead of tables. So that kind of makes sense. So I'm just going to switch that. Now this ID, I used a Java persistence, which is JPA right there. Nope, that's the query. Here it is. It's lumped into this Java x.persistence, but there's an ID import there. And of course, we're not dealing with JPA, so that one doesn't work. However, they have the same or very similar annotation, but for MongoDB specifically. Now, MongoDB has their own type of internal ID field. So where MariaDB, you create your own primary key, basically. MongoDB and Neo4j, I'll talk about that when we get there, also has an internal ID, basically a purposefully unique key, and then you can use your technical keys if you want to on top of that. But this kind of gives an internal ID. And so Mongo has that. It's called an object ID. It's an object that has a couple of fields lumped into it. And they usually term it with an underscore ID field. And then we also want this to be non-null because this is our technical key. And then this, yeah, I'm just going to comment this out for now. But what we actually want to do is we want to say, okay, I have a list of products, because remember with the MongoDB data model that we saw, I kind of skipped that middle table altogether because I nested the line items on the document itself, on the order document. So I don't need that intermediate table or document here. I just link it directly to products. So list product, and we're just going to call this products. Now, if you noticed my data model, you may have noticed that, hey, she named it products with a capital P. You're right. So I have to sync it like this. So this is that mapping that I mentioned. I need to map it to the backend field because it's going to look for something named that on the database side, and there isn't anything. It's actually named this. Okay. So that's in good shape. Now, remember I said that there's no intermediate table here. So I actually am just going to comment this out. So that's done. And then I can shift this and same thing now on the product side. So we have our @document. We're going to use our Mongo ID. Oh, wait, this is a nested document. So I actually don't need a separate ID for the nested document. It's linked with the order document itself. So I can actually get rid of that. And then remove that as well. And I'm still going to take my line item information, but I'm going to store it now on my on the product itself. So the other thing I have to change, I think that's good. Okay. Oh, before I forget. Oh, yeah. This mapping was a little wonky here too. So field, I named this quantity ordered. Ideally, I would have probably, done the import and then worked on the application and then gone back and fixed my data imports on the back end so that it all aligned nicely and neatly, but I didn't. So I have to kind of remap on this side. Okay, the other thing that I forgot is that when I did the import in MongoDB, it did not automatically import this as a date. It did that when I imported into MariaDB, but when I did Mongo's, it just imported as a flat string. So that would be nice to kind of go back and maybe redo the import on that too, get it nice and neat. Okay. And then the only other thing that actually needs updating, so notice this is red, but there's nothing else down here that is. And that is because this annotation, if I scroll all the way up and show you guys the annotations again, is the Spring Framework Data JPA repository query, which we're no longer using JPA, we're using MongoDB. So all I have to do is the exact citation. It's just being sourced from another package. So if I go up here and show you guys now, where did it go? There it is. Okay. MongoDB repository query. So there's the annotation there, and it's sourced in and works fine now. Exact same annotation. It's just getting from a different package there. Okay. Then optimize my import. So that cleans all that up. Hopefully all of the red disappears. It looks like it did. So with that, I don't think anything is missing. Yeah. Okay. I think we're in good shape. We'll find out. If it errors and throws weird stuff at me, we'll know I missed something. Oh, looky there. Constructor. Oh, yeah. I thought I might need to do this. Okay. Constructor there. Okay. So the reason this is because product is a sub document. So it's a child to the order itself. So I need to use the all args constructor because it's not a separate entity. So let's try this again. Okay, it looks happier. Alrighty, so let's switch now and go over to my browser tab. And let's go back to just our generic orders. But remember, we're no longer at 8080, so let's switch to 8081. Hooray, it works. So we have our, this is that MongoDB ID object. So it has a timestamp and a date that gets looped into every ID field. That's their internal ID on each document. And then we have the order ID and the date, and then the nested products. So we have the product ID, the product name, all of our line item information, again, lumped in with products because our data model is a little bit different from Mongo. And so all of that gets looped in nicely and all of that appears well. We're getting multiple orders back. So everything looks good there. Now let's test our other endpoints. So our find by ID, we're going to pass in order ID equals, let's do the same order 10414. So this is returning. So we get our tea time chocolate biscuits and our Guy toast. We have our object ID there, our order ID, everything looks good. So now let's do our fuzzy search. Here, find by product, change this to product name. And let's search for coffee again, just to see if we can, oh, that's not good. Huh, well, oh, I know what I forgot. Okay, so lesson number 1. You can't use JPQL when you're dealing with MongoDB. You can use SQL, however, but one of the really cool things that I found about Mongo queries is that you can use JSON syntax. So I'm actually going to use that. So we have our, let's see, ordered products dot product name. Let me make sure that I named that correctly up here. Nope, I just called them products. So let me just switch this here. Products, product name. So it'll go over, on the orders, it's going to grab products, which goes over to the product subdocument here, and it's going to grab product name. And then I'm going to pass it a couple of basically options, query options. So I want to do a regex, and this is going to pull in the first parameter that I give it. And then I also want to provide, so that's going to do the fuzzy search portion of that. Basically, it's a regex. It'll do the fuzzy search. And then I also want to ignore case, right? Because we want to stick with the same parameters that we had earlier. So I've got this options of ignore case for that. Okay, now let me rerun the app, and we'll go back and we'll run that query again and see if that fixes it, which I believe it should. I don't think I've missed anything now. Okay, so shrink this, go over to, okay, so let's run this one again. Okay, great, that's working. So we get our coffee product back. So it pulls the order, and it pulls all the line, or the sub documents, I should say, for the line items. So products, the product name, as well as the line item information, how many they ordered, any discount, etc. And everything it's pulling has, IPO coffee in it. So now let's see if we can do our Choco and make sure that our fuzzy search is properly working. Yep, so it pulls tea time chocolate biscuits here. And then if we scroll down, let's see if we can find chocolate in here as well. There it is, chocolate. So again, that fuzzy search working well. And I could even specify chocolate, and it just pulls orders with chocolate in them. So all of that is working then, all of our fuzzy search, our find by ID, and just the general find all method. Now that's great and all. Can we go yet another step further? Yes, we can. Let's switch now, and let's jump over to Neo4j. So is this going to be super complicated? No, it is not. One dependency change, reload Maven, and we should be off and running. And I'm going to switch my properties here because obviously these won't work anymore. So Neo4j properties. My application port is now 8082. I've got the URI for the Neo4j database, and then I've got my authentication parameters there. So that should all be in good order. Now let's switch. And as you can see, all kinds of red. So let's fix that. So when we're dealing with Neo4j, we have a node as our domain entity. So we're going to use the @node annotation. This can go back now to the @ID. And notice that this first one here is a Neo4j in the package name here. So same annotation as the MariaDB one. If you notice, it's just I'm not using the JPA annotation. I'm using the Neo4j one. This now can go goodbye because we're going to use the order ID as our technical key. And then that can stay, that's fine. And this can kind of come back. We'll actually, I'm gonna comment that out for a second. We'll come back to the relationships in 1 minute, but let's go ahead and do the product side and fix that because this should be the same as what we just did. So node annotation, this is going to be an ID because it's a separate entity in our database. So we can add these annotations back. Remember that we have that relationship, that physical join basically in our database. So we have our order and we have our product, and then we're storing the line item information on the relationship. So we actually are going to have a separate entity for the relationship because Neo4j elevates the relationship as a separate entity as being equally important to the nodes themselves. So, okay, that is good. We can go back to required args constructor there. Okay, and we'll do the joins, the relationships here in just a second. Let's uncomment this because I mentioned that we've got a separate entity now. And instead of the @entity.table, this is going to be a relationship properties. So this is saying this is a relationship entity. We're storing properties on this relationship. It's not a node. It's a relationship, but we're storing additional properties on that for the line item stuff. We don't need the serializable because in Neo4j, you don't need to store composite key. So what we actually are going to do, there's really no good technical key for this particular entity, and I could create one by all means, but I didn't. So what I'm going to do is I'm just going to use the internal Neo4j ID that is created with the relationship. So again, not super, I would say best practice, but it's just one that works for now. And then all of this stays the same, and then I need to, I'll come back and fix the relationships in a sec. So let's start with order, and let's work our way through the relationships now. So we don't now need this one-to-many, right? But we're going to use, not relationship properties, relationship. There we go. Okay, so it's @relationship, and then we need to specify a type because you can have multiple relationship names or types in the database. So, okay, we have an @includes. We can uncomment this. So we have our ordered product. On our ordered products field, that's going to go traverse across the relationship to that relationship entity that we have right down here. And then we'll come back to the JSON ignore properties in 1 second. Okay, and then let's do the product side. So that way we keep it consistent here. So we don't need our one-to-many here. But we can do our @relationship, and we're going to do includes, and then the direction now coming from product, because order includes a product, so it goes order to product. When we're coming maybe from the opposite side, then the direction needs to be incoming. So we need to specify that on the product side of things, that direction is coming to product, so it's incoming. And then here we can uncomment that, and we'll get back to that in a minute. Now, we don't need it to specify order because we've already tied order to the relationship via this annotation here in the order class. So what I actually need to do is say, okay, we have a target node. Where is this relationship going? So we have a target node of product, and then, yeah, okay, import that. Okay, and that I think should be good. Yes. Okay, so now we're in good shape. And I'll walk through that JSON ignore properties in 1 second. And we did order already. And then, yes, we got it on that side. Okay, so we're good. Now, Neo4j has a similar thing because we've attached all these relationships and we've linked all these entities together and we want to display all these links, then you can end up with kind of this recursion, ugly loop stuff. So we actually are going to ignore some properties. But when we come from order and we go over to ordered product, notice that there's no tie back to order because we've linked it from order to this. So we didn't specify any tie back. So we actually don't need the JSON ignore properties there. Here we've got a JSON ignore properties because notice that product does tie back to that relationship entity that we've defined here. So we will go ahead and ignore this field product orders when we get here. So that way it doesn't come back. And then we can get rid of this. And on this side, we actually don't need to ignore anything either because we're not going back to order. We could absolutely add that, but we don't require it in order to get access to these entities, basically. Okay, nothing else needs to change in the controller. Now, again, same thing here, same annotation, but now we're going against the Neo4j package here. So if I look up here, I should see the MongoDB query annotation that we used earlier. And now I have the Neo4j one here. So there's the Neo4j annotation. So fix that. And then, oops, there we go. Optimize my imports. Perfect. Okay. And now let's go down. One last thing before I forget it again is the query. So custom query, I'm using Neo4j, therefore I can use Cypher. So I have an order, order, well, includes, product. Now I will say the experience on a regex or a fuzzy search is not quite as clean in my mind, at least, as I'm not super regex savvy. So I don't think this is as clean as the, well, really is the SQL, I think, is the cleanest, or the JPQL, but even MongoDB's JSON-like syntax is a little bit, I think, easier to read. So I need to do kind of a fuzzy search, and that's how Cypher does that. And then I need to give it, okay, I want to search for ignore case and then dot star. So again, very regexy there. Then I need to add the product name, basically, that I'm passing in. So the value like choco or coffee or chocolate that I'm passing in there. And then on the other side, I need to do a little bit more regex because it may end differently, right? Choco has chocolate on the end or chocolate on the end. And so then I need to do a dot star there. And then I need to have that in print and then return star there. So when you walk through it and actually look at it, it's not too bad, but just glancing at it is not super fun. So at least not to me. Okay. So, but that is Cypher. And so at least this part, doing the join, remember kind of chaining all those tables together in JPQL. With MongoDB, you were using some regex stuff. You did a little bit of chaining, but because I nested the document, it was a little bit nicer. But this makes it really clean. I have an order that includes a product. Done. Your joins, your connections, your relationships are all in that little phrase there. It was just kind of the regex that was kind of a pain. All right. So I think that should be in order now. And then let's see if everything works. If I've done everything right. Okay, so far the app is happy. So let's go over here. Get rid of all this end stuff. And then, of course, we've got to go against our 8082 because that's our new application port for Neo4j. And this might take a second because it's pulling in a lot of connected data. And all these kind of have a lot of connections. And then, of course, my browser has to render my browser plugin. So we have the order ID and the order date. Then it's going to go across to the line items. And then it pulls the line item information. And then it goes on over to the product entity, or node in this case, and grabs the product ID and product name. So we can see it's pulling back multiples. Looks like all that information is good. Let's see if our other endpoints fared as well. So find by ID, order ID, 414, let's use the same one. So we have our order ID and order date, the line items, it's getting our Guy Toast and our Tea Time Chocolate Biscuits. So that's good. Everything looks good there. Now let's see if we can do this fuzzy search. So let's cross our fingers and hope that I typed everything correctly there. So product name and coffee. Oh no, I missed something. Okay, let me switch back to IntelliJ here. Let me see what I missed. Okay, product name, ignore case. All right, what's it telling me? What's it erroring on here? This is how you know it's live, folks. All righty, nested exception, error code, syntax error, invalid input, expect to not earn an expression. Match where? Oh, oops. Beat up product name. Yeah, I have to match it to a particular property to look for the regex. Silly me. So I'm grabbing the product entity and I'm pulling the product name field off of that. Now if I rerun, I always miss something with those queries. Now if I rerun, we should be in good shape. Okay, it's happy. Let's switch over to browser window. And let's try to search for coffee again. Yes, there we go. Okay, success. So we have our order ID and our date, our line item information, and then on over to the product. And it is pulling coffee. So it is doing that fuzzy search for us. So coffee starts with capital C and it's toward the end of the product name. All good there. Everything with IPO coffee. Now, you might notice something a little interesting here. We haven't pulled the other line items, right? That's because I specifically told Cypher that I want to pull an order that's connected to a product where that product name is equal to the regex, or the fuzzy search term that I'm giving. So I haven't told it, and while you're at it, go out and grab the other products that are also on that order. Notice that with MongoDB and with MariaDB, it automatically did and aggregated and pulled that data in as well. But here, when I wrote my cipher, I did not specifically tell it, hey, go out and grab this other data too. I can absolutely write the cipher to do that. And I can specify, hey, I want you to go out and grab the other line items and retrieve those and pull those back too. Then I would get the same output. But as I've specified cipher right now, I'm just saying, hey, I want to look for orders where the product contains the search term. So that's the difference there. And if I search for Choco, it's going to pull tea time chocolate biscuits, and it's going to pull Chocolate. So it's it's doing the fuzzy search. It's just not going out and grabbing that extra data because I haven't told it to. Let's scroll down. Come on, where's the Chocolate? There it is. It's like, man, it's way down here. Okay, so we get our Chocolate there, and then if I specify specifically Chocolate, it just pulls orders with Chocolate in it. So no tea time chocolate biscuits. That's it. Okay, so our fuzzy search then is working. All of our endpoints are working. It's just a little bit different than what we've seen before. And then same thing, of course, with the MongoDB. The data model was totally different there. And then MariaDB back maybe more what you expected if you're familiar more with the relational database. Okay, so that's in good shape. I'll go ahead and stop my app and wrap up here. So we have just kind of going back over everything we've covered today. Then what are the actual differences? The plain old Java objects need to align with the data models. So in Maria's case, we had that order and product with the join table in the middle. MongoDB, we had an order document and we nested products within that, the line items. And then with Neo4j, we had an order and a product with a relationship between the two that we were able to store that line item information on. The query annotation is also a little bit different. So with Maria, we could use JPQL. You can also use SQL. MongoDB, we saw the JSON parameter syntax. You can also use SQL there. And then with Neo4j, I was able to use Cypher. So those are really the major differences. Remember, I just changed one single dependency in my POM and then off and rolling again. With these changes, there really wasn't a whole lot different on this. So the data model actually is what really truly impacts your application development more than even your choice of database. So what you really need to do is fit the data into a database that's going to create the cleanest model, the simplest queries, and the best application for maintenance, for writing, for features, etc. So the database isn't this monumental, huge, massive decision. You just need to find what fits your domain the best. So with that, all of the code that I did today, all of the kind of getting the databases into Docker containers and import the data and all that sort of stuff is all in these GitHub projects. And I've got all the instructions and steps and everything listed out there. If anybody has any problems recreating it or has questions, don't hesitate to contact me. And then if you want to know more about Spring Data, Spring Boot, and the things that it provides, I've got the Spring documentation linked down there at the bottom. Again, my contact information is up there in the upper right-hand corner. And if you guys have any questions now or even later down the road, don't hesitate to reach out and contact me. Thank you guys so much for watching, and I hope to see you again here soon.
Super cool. Thank you very much, Jennifer. Mm-hmm. That was very insightful and very interesting. That was a cool presentation. Thank you.
This one's a lot of fun.
Yeah. I could tell, even though when sometimes the struggle were getting your blood pressure up, I guess, a little bit.
Just a bit, yeah. This project's also really good at that, yeah.
Yeah. There were a couple of questions, and I think I wanna go maybe for one because it came up about the Spring Data Neo4j. Is that maintained by Neo4j? How is the relationship between Neo4j and Spring Data Neo4j? Maybe you can go a little bit into that.
Yes, so the relationship there is very good. It is currently maintained by both parties. So Spring technically owns the GitHub project, and they'll publish the documentation. Any Spring releases will have any updates along with that. But our project engineers actually write the code, and then it just kind of gets approved and merged into the Spring hub of things. And they work back and forth. If Spring is going to change a lot of stuff, then Neo4j needs to be compatible. And so both sides of the engineers, work together to make it all compatible and work and make it the most kind of feature complete and comprehensive and kind of easy to use as possible. And in fact, I've seen several kind of commits to the main repository that are actually from our engineers. And then I have a meeting with our Neo4j engineers. I help kind of, not really maintenance, I would say, but kind of the awareness and kind of discussion at a lot of the technical content that you might see if you kind of follow me or watch my stuff. I do a lot of Spring Data Neo4j. And so the engineers on Neo4j's side and I kind of work together to produce, example projects and helpful content and things like that around the Spring Data project. So the relationship is very tight. It's very kind of, there's nice feedback loops and all of that. And if anybody has questions and things like that, you can contact us on the Neo4j side or contact the Spring side of things. You can open GitHub issues on the GitHub project, again, maintained by Spring, but that's all there. So yeah, it's well maintained, well kind of a well-oiled machine. So
cool. Okay, super. That was good. I think that was the one question I wanted to pick out. I guess you will share that deck with me, and I can then put it in the description of the video afterwards.
yes.
So if people wanna click through that, that's then that will be available over the next few days. Yeah. Otherwise, follow Jennifer on Twitter if you wanna be updated on all things Spring and more. Yeah, with that, thank you very much. Thank you very much, Jennifer, again for taking the time and presenting this to us. And thank you all for watching. I hope you enjoyed this, and we hope to see you again in one of our next sessions. Bye.